In this video, we are going to talk about what happens in a refrigeration system when we have a dirty evaporator. Now, to make this easy, I'm going to be working in Simutech with a refrigeration trainer to show the different troubleshooting procedures and to show what happens to a refrigeration system when the evaporator is dirty. So we are going to be working with, I'm going to have this set for a reach-in cooler. Our standard refrigerant, I think on this one we're going to use is, we'll go with the 404A. And basically it's an R404A system. It's a medium temp system with the box temp between 30 to 45 degrees. Normally we want it set for 35. It uses a pressure stat. In other words, the pressure of the refrigerant is what actually cuts the system in and out. And I'll show you that in a minute. It has a TXV. We want our amperage of our compressor to be around 9 amps, condenser fan motor 2.5 amps, evaporator fan motor 1.8, and this is a 115 volt system. This would be some type of system you would see behind the line of a restaurant, or maybe under the bar for a bar cooler. It's also very close to your domestic refrigerator you might find in your house, except it probably wouldn't have a TXV on it. So let's go ahead and take a look at the system running normally. Okay, and again, just our evaporator section, our low side is all in blue, high side is in red. This system does have a receiver, it has a filter dryer, it has a sight glass, and the TXV and the TXV bulb. Condenser fan motor, condenser, evaporator fan motor, evaporator. When we look at the schematic of the system, it's a basic ladder schematic. Your circuit breaker is right here. We use L2 is actually neutral because this system plugs in. Our evaporator fan motor is a PSC motor. Our condenser fan motor is a PSC motor because we have a run cap. Our compressor uses a potential relay. Notice the 1, 2, and 5 pins with the start capacitor wired into pin 1, start winding wired into pin 2, common wired into pin 5. Okay, and we have our run windings. Now, we were talking about box pressure stat. What this does is when the pressure of the refrigerant drops below a certain set point, it opens the circuit going to our condenser fan and to our compressor. Okay, so let's say I figure out the equivalent temperature of R404A to 35 degrees. That's what I set the box temp stat as. When it drops below 35 degrees, or the pressure thereof, it opens. In this system, because it's commercial and most commercial systems, the evaporator fan runs constantly. It's the only way we can circulate the air in this cooler over the evaporator to affect the refrigerant pressures. So evaporator fan runs constantly. But my box temp is designed to be over 35 degrees. So let's go ahead. I'm going to power this system on. Okay, currently my box temp is at 45 degrees. Let's go back over to the mechanical side of things. You'll see that my condenser fan is running, my compressor's running, we're pumping refrigerant. Let's put some gauges on here. R404A, we're showing 69 PSI, and it is dropping, but we're showing 69 and 209. If we take a look at my ambient temp, get this temperature probe in here someplace. Let's first get, okay. I want to take a look at my ambient temp. I want to put it on, actually my ambient temp is 75 degrees. Let's go ahead and I'm going to put 2 probes on here. Green is on my liquid line, and then I have on my suction line. So I have 37 degrees, put my gauge to temperature, 37 to 29, 12 degrees. I want my superheat between 8 and 12, so my TXV is doing what it's supposed to do. Because remember, TXVs control my superheat. My liquid line temperature is 88 degrees. My condensing temperature is around 99 right now. My ambient temperature is 75. So I'm about 24 degrees above ambient temperature. I actually want that a little higher. So we're probably going to see that continue to rise a little bit because I really want 30 to 35 degrees. I'm just going to make this run a little bit quicker. I'm going to lock my temperatures in, which I could do on a simulator, can't do in real life, so I'm not going to let that box temp fall. Okay. So now we have a system that is running properly, okay? 8 to 12 degrees superheat, 26 degree evaporator temperature, 100 degree condensing temperature. Outdoor temperature 75 degrees, 100 degrees, okay? We're 25 degrees above ambient. I'm going to accept it for now. Okay, so that's what we do when we're running perfectly. Now, let's go ahead and throw a fault condition in here. So I'm going to exit out to the main menu. I'm going to run a fault. I have a pre-selected fault in here. The complaint we get from our dispatcher is unit not cooling adequately and runs constantly. It's a reach-in cooler, same one we just talked about. So let's go ahead here and we're going to go ahead and power it on to see what happens. Okay, so I have, and I'm going to throw gauges on. I don't normally throw gauges on before I eyeball a system and check everything I can without, but since we're on a simulator, I'm going to go ahead and throw gauges on. You will see that I now have a 90 degree and a 27 degree. Let's throw some temperature probes on because I want to get my superheat and I want to get my subcooling. Okay, so I have a 78 degree liquid line. I have a 33 degree suction line. Now, 27 degrees versus 33 degrees tells me that my subcooling is really, really low. Okay, I mean, it's only 6 degrees. So when we looked at the system working perfectly, my subcooling was 6 degrees. Now, what's going to happen to my evaporator as this temperature continues to drop? Let's go ahead and find out. Okay, so I'm going to allow this box temp to continue to drop. I'm going to drop that down just a little bit manually. Notice what's happening to my yellow side of my thermostat. That evaporator is now under 32 degrees. Okay, my low side pressure is now down to 25 degrees, which is 62 psi. Okay, I'm really after temperature. So my low side is now down to 25. So I have a 6 degrees superheat, which is not good because I'm sooner or later going to start returning liquid refrigerant to the system. Okay, so as my box temp does continue to come down, okay, I'm going to continue to drop my temperature here. 30 degrees. What happens at 30 degrees? We start building up ice on coils. So let's go ahead and see. I think we can actually look at the coil. Okay, I want to look at this evaporator coil. You see what we have going on here? I have airflow, but I also have, believe it or not, if this is clear, it's just going to show me the fins. But I now have ice starting to form on this coil. Okay, and the longer this runs, okay, the more ice is going to form on that coil. So, what do we have going on? Okay, I have a system that has a 6-degree superheat, should have a 12-degree superheat, or at least 8 to 12. I have a low side pressure or a high side temperature that's now 90 degrees with my 75 degrees. So I only have a 15-degree difference. That's not good. I have a coil temperature that's at 24 degrees saturation point. Okay, there's ice that's going to continue to form on that coil, and the system is not cooling the space. It's going to continue to run without actually cooling the box. My box temperature is not coming down the way it's supposed to. If I go to the electrical side, and if I let's put an amp clamp on my condenser fan motor, it's running normally. Let's move that to the evaporator fan motor. We're at 1.8, we're fine. Let's move this to the compressor, we're at 7, okay? 7 amps. Now, if I look at the specifications again, my compressor should be around 9 FLA, okay? And when we measured it early, it was close to that. So what's going on? Well, the dead giveaway is my fans are running normal, which we just found out by amperage, and we can visually see my fans running normal. But my evaporator is not exchanging heat. So let's go and look at our repair options. So what are we going to do? We have an evaporator fan that's running. Okay, we have low suction pressure. So I'm going to say low suction pressure. I'm going to go with the low poor evaporator airflow. Okay, and I'm going to go with dirty evaporator coil because, again, we know our fan is running. We looked at the fan airflow when we looked at the evaporator fan. It was flowing the right direction. Okay, so let's go ahead and click OK. We're going to repair that. Okay, now I have a system running. Look and see what's happening to that box temperature. That box temperature is falling. We now have my pressures are going to start changing here eventually. Okay, so I have an 8-degree superheat. I have an 8-degree superheat. My evaporator is still a little bit low pressure, but watch what happened. My box temp satisfied at 35 degrees. Okay, we shut the compressor off. Okay, notice now I'm blowing air across here, across the coil. 36 degrees. So as that box temp comes up, sooner or later that's going to come back in. So again, between the in point and the out point is my differential. So when we look at this on the pressures, we see 73, 74, 75. My box temp is climbing. We'll just wait a minute here. We hit 79. Box temp, I'm going to just bring it up a degree. 37. We hit that 79 point and we brought our system back on. We're going to let this system run for the box temp to come down to 62 again, 62 psi. And we're going to cycle based off of pressures. But the key part is look and see what's happening to my evaporator. It's now clear. If we take a look at that picture of that evaporator, you can now see the fins. We still have airflow, but we can actually see the fins without ice buildup. So what does a dirty evaporator do? It prevents heat transfer from the space to the evaporator with ice on it, okay? So if I don't have good evaporator airflow, I'm going to bring up ice. My superheat is going to be very low, and I take a chance of bringing refrigerant back to the compressor as a liquid. And remember, my compressor is only is a vapor pump, not a liquid pump.